Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces.
Today, we're talking about something many parents and caregivers have probably experienced. You have a smart speaker, you ask it to play a song, it works. Your child asks it to play a song, and it has absolutely no idea what they just said.
It's a classic problem. Voice assistants are trained on huge amounts of adult speech, and children's voices are just different. They have a higher pitch, they pronounce things differently, and their speech patterns can be less consistent.
Exactly. So tech companies face a dilemma. To make their devices understand kids better, they would need to collect and analyze massive amounts of children's speech data. And that, quite rightly, opens up a huge can of worms around privacy and data security.
Which brings us to today's paper, Zero-Shot KWS for Children's Speech Using Layer-Wise Features from SSL Models. It's a mouthful, but the idea behind it is incredibly clever and could solve this very problem.
Let's break that title down. First up is KWS, which stands for Keyword Spotting. This is the basic technology that makes voice assistants work. It's constantly listening for a specific keyword or wake word.
Right, it's the Hey Siri or the Alexa part. The device isn't really processing everything you say until it spots that specific keyword. The challenge is making the keyword spotter accurate, especially for kids.
Now for the second part of that title, Zero-Shot. This is the really cool bit. In the world of AI, zero-shot learning means you're asking the model to do something it was never explicitly trained to do. In this case, the researchers wanted to build a system that could understand children's keywords without ever being trained on children's voices. They would train it only on adult speech and then, without any extra practice, see if it could make the leap to understanding kids.
It sounds like magic. How could a system possibly understand a type of voice it's never heard before? The secret sauce is in the last part of the title, SSL Models.
SSL stands for self-supervised learning, and it's one of the most powerful ideas in modern AI. Let's try an analogy. Imagine you want to teach an AI to understand language. The old way, supervised learning, is like giving it flashcards. You show it a picture of a cat and the word cat. You do this millions of times. It's effective, but you need a ton of labeled data.
Self-supervised learning is different. Instead of flashcards, you give the AI the entire internet's worth of books and articles. Then you play a game with it. You give it a sentence with a word missing, and you ask it to guess the missing word.
Like, the cat sat on the blank. The AI has to figure out from the context that mat or chair is a likely answer. By doing this billions of times, it doesn't just memorize words, it learns grammar, context, and the underlying structure of language all by itself.
These SSL models for audio, like the one used in the paper, Wave2Vec2, Hubbard, and Data2Vec, have done the same thing but for sound. They've listened to countless hours of unlabeled audio, learning the fundamental patterns of human speech. They've basically taught themselves what speech sounds like in incredible detail.
So the researchers' big idea was, what if these models have learned something so deep and fundamental about speech that the differences between adult and child voices don't matter as much anymore?
That was the bet. They took these pre-trained SSL models and used them as a very sophisticated feature extractor. Instead of feeding the raw audio into their keyword spotter, they first passed it through the SSL model, which translated the sound into a much richer, more meaningful representation.
And then they ran the experiment. They trained the system on a dataset of adult British English speakers. Then they tested it on a completely separate dataset of children's speech, aged 4 to 14.
And the results were fantastic. The system using the features from the SSL models dramatically outperformed the traditional methods. The model named Wave2Vec2 was the clear winner, showing a huge improvement in accuracy. It was much better at catching the keywords it was supposed to do, and had far fewer false alarms.
But what I find most fascinating is which part of the model worked best. These AI models are built in layers, a bit like a skyscraper. The first few layers process the raw sound, picking up on basic frequencies and tones. The higher up layers handle more abstract concepts.
And the researchers found that the sweet spot was way up high, specifically at layer 22 out of 24. This tells us something really important. The early layers were probably still getting tripped up by things like pitch. A child's hello and an adult hello look very different at a basic sound wave level.
But by the time the information got all the way up to layer 22, the model wasn't just hearing sounds anymore. It was understanding the linguistic content. It had extracted the abstract idea of the word hello, regardless of the pitch or pronunciation of the person who said it.
That's the breakthrough. It's robust enough to handle the acoustic differences between adult and children, and it even performed significantly better in noisy background conditions, which is another huge challenge for voice assistants. So what does all this mean for us? It means we are a big step closer to having voice-activated technology that works for everyone in the family, from toddlers to grandparents. Think about educational apps, smart toys, or communication aids for children.
And crucially, we can get there without creating massive, privacy-invading databases of children's voices. By using AI that's smart enough to generalize from adult speech, we get the best of both worlds, performance and privacy.
It's a perfect example of how clever thinking and better AI design can solve a problem more elegantly than just throwing more and more data at it.
So the next time your smart speaker understands your 5-year-old, you might just have a zero-shot self-supervised model to think. That's all for today's episode of Daily Papers.
Thanks for listening.